Welcome to Raw Machines, a journey exploring the most impressive processes around the world. In today's episode, we will follow a tree from the deep forest to the most modern sawmills and paper factories in the United States. Each destination reveals a different cross-section of the wood industry, a place where advanced technology and human experience merge. Now, don't look away, and let's start the journey with me. The American forest in the morning always possesses a unique stillness. The air is thick with the smell of sap, and sunlight filters through the canopy of old-growth trees. Against this backdrop, harvesting activities are not as noisy as one might expect. It is a harmonious blend of modern technology and a respectful attitude toward the resource that has sustained many generations. The centerpiece of the process is the multifunctional timber harvester. Seen from a distance, they look like powerful metallic creatures working deep in the forest. Their hydraulic felling head is a sophisticated structure. In minutes, it can firmly clamp the trunk, sever it, remove branches, and cut it into sections with near absolute precision. On the screen, the target length is clearly displayed. The operator presses a button. The long trunk is cut into precise segments, 12 feet, 16 feet, 20 feet, depending on the intended use. In the past, the sawyer had to stand next to the log, measuring by ruler, measuring by eye. Now, the machine does the heavy lifting, but the decision of where to cut and how to buck the log to maximize its value, that remains the work of humans. When the logs are neatly bundled, the work shifts to the logging trucks. The long chassis, the upright steel stakes, and the articulated steering system allow the body to flex according to the terrain's curves. This is not the typical truck seen on the highway, but one born to withstand harsh conditions such as mud, potholes, and steep inclines. Leaving the forest, the wood's journey officially moves into a new chapter. To passersby, it is just a log truck, but for the sawmills, it is the source of life, the input for an entire industrial ecosystem. portion of those logs will head to Pulping Lumber Company, one of the sawmills considered a legend in northern Wisconsin. Pulping Lumber Company is not an unfamiliar name to local contractors, woodworking shops, and material stores. For decades, they have built their reputation on consistently producing 400 to 500 logs per day, maintaining uniform quality, delivering on time, and always being present at construction projects that require good timber. The wood arriving at Pulping comes from all over Wisconsin. People joke that if you stand here all day, you will learn the language of wood simply by looking at the color and grain. White pine is lighter and softer, but highly valued for its ease of machining and wide application in construction. Red pine is stronger, suitable for structural use or outdoor applications. Spruce. A large part is used for construction and paper production. Each log is an economic value problem, and if processed smartly, the wood will yield many product combinations with very different values. The Tiger Cat machine lifts each log piece and places it onto the feeding table. From there, the wood is pushed into the debarking machine. The debarker must remove the bark clean enough to show the wood fibers, but without damaging the wood grain. This protects the saw blades from dirt and bark and helps the subsequent scanners see the surface. Next, logs pass a metal check. High-power magnets look for hidden items like old nails or screws. If metal is found, the log is pulled out for recheck before moving to the next process. The Pulping Mill runs on 2 McDonough band saws, one east, one west. The blade is a huge steel band, 14 inches wide and over 12 meters long, running on 2 big flywheels. Crucially, it cuts both ways, cutting wood when the carriage moves forward and back, which doubles the speed. Every cut is critical. A wrong decision means wasting wood. So, the workers here are not just operators. They must truly understand the wood and the machine, knowing exactly when to stop and cut. Leaving the carriage, the boards still have mixed widths and curved edges, so they need trimming at the edger machine, custom built by TS Manufacturing for Pulping. It doesn't just cut straight. When necessary, it curve saws exactly along the board's natural contour to retain the maximum amount of wood. The result is that each board exits the machine with optimal width, even edges, and square corners. The cutoff edges, which often contain defects, cracks, or curves, are immediately transferred to the residual area to continue another journey. In the past, wood waste was an issue. Now, it's a resource. At Pulping, sawdust goes to a pellet plant, wood chips are sold to paper mills, and bark is used for mulch or burned for heat. Looking at Pulping as a whole, the philosophy is obvious. If a tree took 100 years to grow, it is our duty not to waste a single part of it. After sizing, boards are trimmed to remove cracks or decay. The grader quickly checks the grain, knots, and straightness to assign a grade. The sling sorter scans the dimensions and automatically groups boards of the same size and grade into one bin. When ready, the automatic stacking system takes over. Boards are lifted and stacked in neat layers with spacer sticks placed between them to allow airflow for drying. In just 3 to 4 minutes, a whole huge pack of wood is stacked, waiting to go into the kiln. The kiln at Pulping can hold about 300,000 board feet of wood at once. When the doors close, the temperature, humidity, and airflow are tightly controlled. For about 7 days, moisture slowly leaves the wood. After drying, the wood is in a rough, dry state. It then goes to the planer for final finishing. Here, the planer smooths the boards and cuts them to the exact size requested by the customer. Finally, the packages of wood are strapped, labeled with the Pulping brand, and loaded onto Pulping Nasoga branded trailers. For Pulping, the core value lies in controlling the entire journey themselves, from the round log to the finished board. They believe that only by holding that thread in their hands can they maintain quality, keep their customers' trust, and uphold the reputation they have spent a lifetime building. If Pulping tells the story of wood into lumber, then Pixel Specialty Solutions tells a different story, wood into paper. Both start from the forest, but end with very different products. Pixel is not only proud of its paper pulp line, they talk a lot about the forest. Because Pixel is one of the first enterprises in the Pennsylvania and Maryland region to develop sustainably managed forests. Simultaneously, Pixel invested over $100 million to convert from coal to clean natural gas, significantly reducing carbon emissions. In an era where people are increasingly concerned about their environmental footprint, that is no longer a plus point, but part of their responsibility. Their factory also holds triple chain of custody certification from FSC, SFI, and PEFC, 3 reputable forest certification systems. It's like having 3 layers of visas for their products to travel around the world with the designation Sustainably Sourced Wood. In the woodyard, trucks continuously deliver logs and chips. Softwood, pine, spruce, is separated from hardwood, oak, maple, ash. Logs go into huge debarking drums. The resulting bark is collected to be used as biomass fuel for the self-sustaining energy system. Debarked wood moves to the chipper, where it is cut into 1x1-inch chips. These chips are screened to remove any flaws. Sawdust and fine waste go to the biomass boiler to generate steam and about 40% of the plant's clean electricity. Some trucks delivering chips perform a rather surprising maneuver. The trailer body tilts a full 60-degree styles to dump the chips into the storage bay. From there, conveyors pull the chips up, sort them, and place them into different reserve piles, awaiting the cooking order. In the digester, wood chips are mixed with white liquor and heated to 170 degrees. This heat breaks down the glue, leaving soft cellulose fibers. After cooking, the mixture consists of pulp and black liquor. The black liquor is separated for chemical recovery and used as fuel. The pulp is washed, screened, and filtered to remove uncooked wood fragments, knots, and then passes through an oxygen delignification step. Oxygen combines with steam, attacking the residual lignin. By doing this, Pixel significantly reduces the need for strong bleaching chemicals. The bleaching process involves multiple steps using ECF technology. From its initial brown color, the pulp gradually becomes bright and white, meeting the standard for producing printing and writing paper. The refined white pulp goes into large mixers. Long fiber softwood adds strength, short fiber hardwood adds smoothness and opacity. Blending these controls the paper's properties. The chest also contains fillers like clay, calcium carbonate, or TiO2 to increase whiteness and smoothness, sizing agents to prevent the paper from absorbing ink, and brightening agents to give the paper the familiar blue-white shade. The furnish is pumped into the head box and sprayed onto a moving metallic screen. Water drains downward, leaving behind a thin layer of fibers. Sometimes the machine adds a top wire to press the water out faster and make the sheet more uniform. At the end of the wire section, the layer of fibers meets the couch roll, where the future sheet of paper first appears, though it still contains more than 80% water. Next, press rolls reduce the moisture content to about 65%. The paper then passes through a series of steam-heated drying cylinders, gradually drying to a moisture level of 4 or 5%. If needed, the paper is coated with a thin layer of starch to increase surface strength and improve printability. The finished paper rolls are sealed with poly or moisture-resistant craft paper. Both ends are covered with cardboard caps, glued, heat-pressed, and clearly labeled. Everything is gently loaded onto trucks by specialized clamp forklifts without damaging the rolls. Pixel tracks every vehicle using the Forkite system, updating the route every 15 minutes. Thanks to their inventory, they can offer next-day delivery to about 90% of U.S. territory. The white sheet of paper you are holding may very well have traveled that entire path, from a tree in the forest, through the factory as an amorphous mass of pulp, finally transforming into a delicate sheet of paper, a small object, yet powerful enough to carry human knowledge. While Pixel transforms a small part of the tree into paper, Brightite Mill is where the backbone strike of the wood continues its journey to become boards and timbers for construction, furniture, and structural use. If Pukal has the appearance of a modernized family-run sawmill, then New Bright Mill resembles a purely industrial machine, vast, fast, and precise. The new day at New Bright Mill begins with the sound of trucks backing into the yard. Logs from the forest are successively unloaded. The wood is sorted into groups by species, size, and intended use. The large straight logs with few defects are reserved for structural products. Smaller logs, which may be curved or knotty, are designated for boards or panels. The goal here is always clear: optimizing the production line and minimizing waste. When the logs enter the building, the saws cut through them cleanly. The production engineer pre-calculated the cuts to get the best yield, standard sizes, and respect the wood grain. Conveyors link the machines, moving the boards from the saw to the next areas. They align the boards, keep them stable, and reduce vibration to ensure the lumber is always in the right spot. In the subsequent production lines, the wood is sanded, planed, and the surface is flattened. Rotating drums, sanding belts, and planers sequentially process small ridges and tiny knots, creating a smooth surface ready for spraying paint, veneering, or joining. Above, sensors measure thickness and flatness. Below, humans assess by hand and by eye. Any board that deviates from the standard, even slightly, can be rerouted for reprocessing or rejected. Quality checks are scattered across the line in multiple stations. Each station acts as a small gate to ensure the final product is consistently high quality. In addition, the mill's energy system is powered by two 3 MW biomass boilers, which supply heat for all the dry kilns and buildings on the premises. The fuel source for the boilers is a mixture of byproducts like pine bark and wood fines, materials that might seem like waste but are fully utilized. Thanks to this closed-loop operation, no part of the wood goes to waste. Finally, the standard compliant boards are stacked by size and quality. The packages of lumber are bound together, ready for storage or delivery. New Bright may not offer the romantic narratives of sustainable forests or environmental certifications, but it is the embodiment of an important truth. Without these high-capacity mills running smoothly every day, the global timber supply chain simply could not operate efficiently. Now, we will leave New Bright and head to Fort William, the final destination of our journey. Fort William is a modern industrial facility, part of a chain of pioneering mills that utilize high-efficiency automation lines. Here, the impressive factor is not the individual machines, but the coordination between humans and machines. The raw lumber is fed into the system via tandem in-feed clusters. Multiple pieces of wood can enter at the same time, not chaotically, but maintaining their individual spacing and position. The boards pass through various sawing machines. Some specialize in lengthwise cutting, some in crosswise cutting, and some both cut and profile the edges. Each cut is a moment of destiny determination. This board will become flooring, that one a structural stud, and another one a wall panel. At Fort William, the engineer doesn't stand next to the saw blade, but next to a screen. Yet, they still must understand the wood. If the wood changes, wetter, harder, more knots, the parameters need to be adjusted. After cutting, the boards go through a series of inspection stations, some checked by workers, some measured by sensors. Thickness, straightness, warp, surface quality, all are evaluated. Boards that do not meet the standard can be automatically diverted to another lane for reprocessing or removed entirely. The crucial point is, despite the high level of automation, humans are still present. They don't always touch the boards, but they monitor the screens, listen to the machines, and sense the operating rhythm. They are the conductors for the machine orchestra. Once sanded, inspected, and repositioned, the boards are collected at the end of the line. Here, they are sorted by size, grade, and application. A portion proceeds to specialized finishing lines, lamination, surface coating, further cutting, and custom order processing. The rest are stacked, bundled, and moved to storage, awaiting shipment. Looking back at Fort William, we see a picture different from the quiet forest scene at the beginning. Gone is the sound of wind rustling through the leaves, replaced by the sound of motors, chains, and conveyors. But both are part of the wood's journey. One is where the wood is born, the other is where the wood is redefined for its service life. Ending this journey, we see the seamless picture of a single tree. From the deep forest, it passes through human hands and technology, finally becoming the material of modern life. At Pukal, the tree enters the world of the bandsaw, the debarker, and the dry kiln. Every slice is a blend of algorithm and experience, creating boards that appear simple, but are calculated down to the last millimeter. At Pixel, the smallest part of the tree, the wood chips, takes a different destiny. Delignified in the digester, running through the bleaching line and the paper machine to become the white sheets used for education, office work, and printing. New Bright Mill continues with sheer industrial power. Round logs are sorted, sawn, planed, and continuously inspected. High capacity, high productivity, yet never forgetting the crucial human role in maintaining quality standards. And at Fort William, the wood's journey concludes with final refinement. Conveyors coordinate the panels, and the cutters and sanders operate rhythmically, turning raw wood into finished products ready for the market. Though each location has a different task, they all share one principle: maximizing the value of every log, minimizing waste, and respecting the resource nurtured by nature for decades. Technology helps accelerate and raise standards, but it is humanity that is the inheritor and keeper of the craft's soul. The journey of wood, from forest to factory, from tree to material, is a harmony between nature and industry. It reminds us that extraction does not mean destruction, and production does not mean waste. As long as mills and factories like Pucall, Pixel, New Bright, and Fort William uphold their professional ethics and spirit of sustainability, the wood's journey will remain proof that humans can utilize resources while still respecting the place they originated. This is the synthesis of tradition, technology, and preservation, a story we continue to write, one board at a time. Thank you for listening to the end of the story. If you also enjoy similar videos, please hit the like button, share, and subscribe to the channel so you don't miss any exciting stories to come. Raw Machines says goodbye and see you again.